Hello and welcome to the last heap level, Protostar heap level 3. The level description says this level introduces doc Lea Malloc, dlmalloc, and how heap metadata can be modified to change program execution. Okay, so first of all I have to say that this is probably the hardest level I've done from export exercises so far. It took me a lot of days of frustration, and after a lot of time and a little help from a team member from Open to All, I was able to solve it. Let's first check the source code. We have in the main function we allocate 3 pointers, character pointers. Each one allocates 32 byte. Then we copy our arguments. We have to provide 3 arguments to those chunks, and we free them backwards from C to A, and afterwards we print out dynamite failed, and we have a winner function too, which prints out that wasn't so bad now, was it? Okay, so obviously we want to jump to the winner function and print out that wasn't too bad now. Yes, so basically if we this dlmalloc implementation says that every time you free, we have in the chunk we created and backwards pointer and forward pointer. Both are for optimizations because the computer wants to combine those chunks to a big chunk again, because then we don't have those little chunks all the time. So I can illustrate this with GDB. So let's first run the program in GDB. -q heap3. Let's set the disassembly flavor to Intel. Let's then, this is main. So now we are going to break on several points. So first we will break it after every string copy and after every free. So let's get those str copies first. So break here first, then we are going to break here, then we are going to break here, and we're going to break at the last free, so there. So let's run this program with AAA, BBB, CCC to see the implementation. Okay, so let's check the heap. So we want to print out the heap every time. Info proc mappings. Oops, mappings. So there is the heap. So we will examine 64x and then the address. So there we can see the heap. There we have the 3 chunks. There is the first one. There is the second one. And there is the third one. And we see that after the first str copy, we already put those A's here. Then we will continue, print it out again. Then there are the B's. Continue, print it out again. There are the C's. So we now are at this point at line 23. And next we free C. Oh shit, sorry. My bad, we have to run it again. So continue, continue, continue. Now print it. So now we are done with all our frees, with the 3 frees. there we see some addresses in those chunks, and not in the last chunk, because obviously we have no backwards pointer at the last chunk. So we want this is a forward pointer to the next chunk. You can see it at the address. This is C028. This is C030. Or this is at this point. No, at this point. Sorry, at this point. So to the next chunk. Here it is as C050, which is this one. So this is a pointer to the next chunk. So now we are done with the GDB stuff, and we already understand what the free does and the string copy and so on. And so let's think about what we want to do. So first of all, obviously we want to print out, we want to jump to winner and not print out dynamite failed, or we can print out dynamite failed, but at the end we want to result in printing out this one. What do we need for this? For this how can we do it? We can do it with, as we did in some levels before, we can overwrite the puts at the end. So that's this as main again. So the puts here, this is this one. We can overwrite this jump, and instead of jumping to the GOT, because this is in a GOT, so XS, I think it should work. Yep, in the global offset table. So instead of jumping to the global offset table, we can overwrite it and jump to the winner address. So this is what we want to do. So what do we need for this? First, we need the address of winner. Second, we need a shellcode which calls the winner function, because we will then call shellcode. And third, we need chunks here which allow us to jump around on this heap and then to overwrite GOT. So we cannot do it with the current setup because we only have forward pointers. We can use it, but we can use forward and backward pointers, and as in the dlmalloc implementation, it says that there is forward and backward pointers. So this is what we will do. So we will overwrite the forward and the backward pointer to jump to shellcode, and to overwrite the puts call on the global offset table. So first let's get the address of winner. Let's do it with object dump -t Protostar bin heap3, and let's grab for winner. So this is the address. So let's copy it. The second point, we need shellcode. So how do we create shellcode? To create shellcode is pretty easy. We can create it by hand. We cannot create it on the Protostar VM, but you just need a Linux system to do it. So grant SSH. I will log on the Ubuntu system for now. So the password, let's mute me real quick. So, okay, now I'm on the Ubuntu virtual machine. Let's go to cd home itsec wargames exploit exercises Protostar heap3. So there's nothing in here. So first if we want to create shellcode on our system, we have to write assembler code. We have to make an object file out of it and link the object file, and then we can check the string literal literal, what you see in shellcode all the time, or what you use to basically put it somewhere and call it then. So first we need assembler, so we will make a heap3.asm for assembler. So let's first give it a section.text. So, next one, we need a global start. So we will start at, for example, let's like a main entry for assembler, and then we will define start. What we will do, we will move an address to EAX, and which address will we use? Which address we will move to EAX is the address of our function, of the winner function, and afterwards we will simply call EAX. So what we have done here, or what our assembler it will copy an address to a EAX and will call it. So this is a basic call of our function, of our winner function. So now we have the assembler here, the assembler file. Next we will create an object file, another Mr. tool, an asm -f elf file is what we want to do. We will want to sample this sample file, and object file we call heap3. So now we have our object file here. So file heap3 is an elf relocated 32-bit. Next we will link it. We will use ld, the linker for this, -m elf underscore i386, because it's 32-bit and our system is my system here is 64-bit. I have to define how that I want to link it in 32-bit. So then we will output it the file h3 heap3, and what file do we want to link? It's this object file. So now we are done, and there is a file heap3 which is an executable. Now we will check out object dump -d and heap3, and there we can see our move, our call, and those are the string literals. So our string literal for Python, for example, at the end will be b8 64 88 04 808 ff and d0. So let's copy it. So this is our shellcode. Okay. So next we will. So now we have our address of the winner function. We have the shellcode we need. And next we want to create our own chunks and our heap chunks, and create the heap like we want to use it. So what we need is an extra chunk with a forward pointer and a backward pointer. We will use the forward pointer for the puts address, for the address of puts in the GOT, and we will overwrite this puts address with the shellcode. So we will jump, instead of jumping to puts on the GOT, we will jump to our shellcode, which we just created the string literal. First we need the address of puts, and we will do it with object dump again, object dump -r opt protostar bin heap3 3, and we will grep for puts. So this is the address of puts. There is one interesting point here. We cannot use this address. Why? Because at the first string copy we add to EBP 0xc, which is 12. So we have to subtract it again with this address. So our puts, or our actual puts call Python is this one minus 0xc, which is this big number and which is in hex this one. So we have to remember this one as the address of puts. This is very important, and this was very hard to track at the first try I did this level. So keep that in mind and always read the assembler. So let's think about how our heap should look like. Yeah. So first, so we have three writes we can use. We can write there, and we can write there. So how do we use the first chunk? The first chunk we can use basically as a container for our shellcode. So we will put there our shellcode somewhere in the first chunk. We will use the third. I said somewhere because it's a bit tricky, because we cannot use put it there at the first place. We have to put it here because we obviously make 3 frees, and every free our heap chunks changes. So we have to put it at this address or at this one. So basically just have to move it around in a chunk and find the right position for it. How do we use the second chunk? So this is the second chunk. So the second chunk is a pretty critical one, because what do we want to do with the second chunk? With the second chunk we do not want to change the size of 0x29, but we want to overflow it up to the end to the third chunk and change the size of the third chunk to a bigger size, to a size which is bigger than 80 bytes, and the last bit is set. Why bigger than 80 bytes? Because if it's bigger than 80 bytes, we can use this unlinking exploit, or unlinking. Because of the unlinking, we can use an exploit, which we will use obviously at the end, and therefore we need files bigger, chunks bigger than 80 bytes, because otherwise it will use a faster unlink and not the unlink one we want to do. So and the third chunk is the interesting one, because the third chunk is the chunk we create by ourselves. So at the end there will not be a 0x29 here, there will be a 0x61. Why 61? Because it's basically bigger than 80, and it's the last bit is set, so this is because of the one. You can use any number bigger than 80 and the last bit set. To do this with the third chunk, what to do with the third chunk? So in the third chunk we obviously have a big it will be a big chunk, and basically at the end we will have a forward pointer and a backward pointer. The backward pointer is the puts address, as I said before, and the forward pointer is the address to the puts on GOT, and the backwards pointer is the position of the shellcode in the first chunk. So, for example, to this address, which would be 10.4 14. So C014, which is this one. And for this unlinking stuff, we will use a little trick. We will move our FD, which is our forward pointer, and BK, which is our backwards pointer, 2 addresses to the left. We will shift it. But we cannot put null bytes, and we cannot put -4s at these addresses here, which will cause this shift at the unlink. But there is a little trick in a frag article. I can check the link. Whoops, my bad. Not this one. What have I done? I want to copy it. So, yep. So on this frag article, there is a very interesting article, Once Upon a Free, which explains, there it is. The values we set on a previous size and the size do not matter, but 2 conditions have to be met in this case. It should work. The least significant bit or size has to be at 0. Both brief size and size should be at safe to a pointer that is read form, because we cannot read null bytes, to avoid null bytes. Values such as FFFFC, you have to ensure that there is chunk boundary size +4 and the lowest bit is zeroed out. So FFFC will work just fine. So we will put there 2, somewhere here, oops, 2 0x FFFC for 2 - 4 to shift our backwards pointer, which our forward pointer, which would be here, and our backwards pointer, which is here, 2 times to those addresses for the unlink. So this is a little trick you can use from this website. I will put the link in the description too. Okay, so let's form our text string. So we have one bigger text string, which will be after the heap3, after the binary call, and 3 because we can put there. We have 3 argvs. We have to provide 3 strings, which will result in 3 attack strings. So first a text string. In the first text string, we want to basically put our shellcode somewhere here in the what's it called? In the in the first chunk. So we want to put our shellcode right there. So we have to put some stuff right in front of it. So let me think, how do we do it? The simplest way, I will just demonstrate it right here. Those are text strings. So, oh no, we can't just use it here. So run it with Python -c. So first a text string. First a text string will be some values. So let's call so whatever we can use here, A, B, C, E, 4 values, because 1 times 3 to write it right in the middle. So you want to write here. So A, B, C, D 3 times plus. And then our string literal, our shellcode. So let's copy it. There is our shellcode. So the second one. Oh no, just run it now. Just run it. Let's continue. Let's run it. Let's continue. Can we check? this one really quick. Now let's run it again. Continue. Yeah, the problem is I cannot exit it. I have to do the 3 attack strings. Oh, I'm retarded. Now it's working. So now you can see. Oh, we already freed. So let's form it a bit easier, in my opinion. Let's form all 3 attack strings right here first, and then we will see it. So how do we do it first place? So how do we explain it? So the first, there's a good picture here because I have the heap here, and I can write the string here, the attack string here. So the first attack string we already did. We have 3 values right here. You can put whatever you want there. Then there will be our shellcode, which we will jump to in our third, third chunk. So second chunk, and second attack string will override everything up to this point and will create will edit the third chunk to a very big value, and the value will be 0x61 because it's bigger than 80 and the last bit is set. So we can check it here. 0x61 is 97, so it's bigger than 80. Yep. How do we do it? We will just Python -c. We will print out some values. So let's print out A, B, C, D again. This time we want to print it out 1, 2, 3, 4, 5, 6, 7, 8, 9 times. And then we want to add 61. So this is pretty simple, pretty straightforward. And then we have a third chunk, and the third chunk is now the size of 97 and 0x61. And this is the interesting one, because this one has these FFFCs I just mentioned from the Frag article in there. So how do we do it there? So we will Python, Python -c. We will print out, first we will print out up to the end of the chunk. Let's print out A, B, C, D again. This time 22, so you can calculate it within this 97, or which is 96 if you leave the last bit, and you need the last 4 addresses for your stuff. So first we need the first shift of 4, or the first -4, which is this. Then we need the second shift, so another -4, which is this one. Then we need the address of puts, which will be resulting in the forward pointer after the free. So 1C, B1, 0, 4, and 0, 8. So this is our forward pointer after the free, and is the puts on the GOT. So on this third value we need is the place where our shellcode is, so what we want to override the puts call. So this is 14 because our because of the first attack string, our shellcode will result in this place, which is this is 0, this is 0, this is 4. So it will be at this address plus 0x4, so 14 C0 04 08. So this will be our third attack string. So let's try it with the GDB, the 3 attack strings. So first we will create a new GDB session. We will set our disassembly flavor to Intel. We will this says main. Then we will break several times. So first, we will break this time after every string copy, after every free, and after the puts call. So first str copy is this one. Second str copy is this one. Third one is this one. Then we go to the first free. First free is done here. Second free is done right here. And the third free is done right. Nope. Is done right here. And then we will break after the puts. Okay. Before we start, we will define a hook to print out the heap all the time, because we want to see how the heap changes. And we'll end. Okay, let's run it with our 3 attack strings. So let's start with the first attack string. Which will place our shellcode. A second attack string, which will overflow the second chunk and result in creating a new chunk. And let's write to the new chunk our 2 minus 4s, which are those, the puts on a GOT, and the place of our shellcode. Let's run it. So first we see that there are, after the first str copy, we see the shellcode at this place right here. And there are our 4 ones, so our A's. Second, continue. We will see still that there is our shellcode, but now we will see the override up to this point, and there is the 61, so we create our new chunk. Yep. So, oops, sorry. Continue. So now we see that we write to the third chunk up to from this point up to the end. We will write up to the end from this chunk here. There are our minus 4s. There is the puts on the GOT address, and this one is the position of our shellcode. So this is our forward pointer. We forward into GOT and overwrite it backwards with the shellcode. And the shellcode will just call the winner function. So let's continue. Now we are at the first free. We can see, if we compare both, that that there is something changed right here. So after our shellcode, we have now the address of puts. This is the first link, the unlink. Then we will continue. Now it freed some stuff right here, which is in the second chunk. So there's an address, and there are some more addresses now too. Let's continue now. And now the third chunk is freed. So now we will just single step. We can see now that nothing is really changed because I think I messed up at this point. Let's single step one step further. Now you can see, yeah, right. Sorry. Now you can see that we are at the puts. Now we single step one step further. Now we were at this point. Now we are this was the last three, obviously. So the call before we sit right here. Then it sees, okay, we have to we sit at puts. Now we single step one further. Now we are here. So it doesn't know where this is. So it just basically jumps there, which is right here where our shellcode is. 19. And now we are at the winner function. So let's continue. And that will do some stuff now. And we can just continue. And we have a segmentation fault because no, you have no segmentation fault. The segmentation fault is right at the end because we don't exit the winner function correct. But we can read something here. That wasn't too bad now, was it? Pretty cool. So we can run it outside of GDB2. So let's grab our attack string, this one. Let's copy it. Let's quit GDB. Let's call heap3 and our attack string. And then we will print out. That wasn't too bad, was it? Pretty cool. So let's recap this level. First of all, as I said right at the beginning of this episode, that this was very hard. It took me a long time and I needed a lot of help, or some help at least. What I've done basically is I've overwritten the puts call on GOT and replaced it with an address of shellcode, and the shellcode just calls the winner function. And you have to be a bit let me scroll up a bit. You have to be a bit creative at this point because you have to create your own chunk at the end, and the own chunk at the end will uses this exploit from the Frag magazine with the shift -4 here, and we'll put the puts right at this address and the address of the position of the shellcode at this one, because -4 plus -4 is -8 obviously, so it will shift each of these addresses 2 times to the left. And yes, this is the basic point in this exploit, the unlinking exploit. So this was now every level from Protostar heap3. There is a heap4, but it does not exist right now. So my opinion, the heap levels were, the first one was pretty easy, the second one was harder, and the third one was extremely hard in my opinion. But I learned a lot, and I did understand how it's working. And every time you solve a level, in my opinion, you should not just try to solve it with an already existing exploit. And if you use an already existing exploit, you should understand it and how it's. Someone had a good idea and had put some thinking into this level, and you should understand it and use it for other exploits on, for example, CTFs. And last week I had a CTF and I was able to use this unlinking exploit right there. What was a bit harder in my opinion, but I already knew what I wanted to do, so it helped me a lot that I did this level. So thanks for watching and see you next time.